Over the past few days, we've taken a look at solving systems of equations by graphs, tables, and by substitution. Today we're going to look at one last method to solve a system of equations, and that method is called elimination. The goal here is to eliminate one variable by multiplying one equation by a number so that it creates an opposite value for one of the variables. Then when we combine the two equations, they'll eliminate each other. So our first example here, we see we have 5x minus 6y equals 3 and 2x plus 12y equals 12. If I were to multiply this top equation through by 2, then each one of these would increase by a multiple of 2, and I would produce negative 12y in the middle, which is an opposite value of positive 12y for my second equation, and when I combine them, I would eliminate them. So let's see how this works. 2 times 5x is 10x. 2 times negative 6 is negative 12y, and 2 times 3 is 6. Now my second equation remains the same, and I'll just copy it down. Now I'm going to add these two, or combine these two equations. 10x plus 2x is 12x. A negative 12y and a positive 12y cancel each other out, and 6 plus 12 is 18. Now, to get x by itself, I'm going to divide both sides by 12, and x is equal to 3 halves, or 1.5. So I've eliminated my y, and I was able to solve for x. Now I can go back into one of my original equations, we'll take this second one here, and find the value of y. So 2 times my value of x, which was 3 halves, plus 12y is equal to 12. 2 times 3 halves is 3. Plus 12y equals 12. Subtract my 3 over, and I have 12y is equal to 9. Divide both sides by 12, and y is equal to 3/4. So I've now found my value for x and y, and I say the solution to this system is the ordered pair 3 halves, 3/4. Let's take a look at another example here and see if we can continue this understanding of how to eliminate a variable. All right, in our second example, we have 2x plus y equals 1 and 4x plus 3y equals 9. We're going to start by multiplying through this top equation by negative 3 so that we produce an opposite value of this positive 3. So let's see how this works. We have negative 3 times 2x is negative 6x. Negative 3 times a y is negative 3y. And negative 3 times 1 is equal to negative 3. The second equation just gets copied down. And now we combine our two equations. Negative 6x plus 4x is negative 2x. The y's cancel each other out. Negative 3 plus 9 is equal to a positive 6. Divide both sides by negative 2. And, negative 2. And x is equal to negative 3. So again, once I've found my value for x, I can substitute it back in for one of my original equations. We'll take our first equation here, 2 times negative 3 plus y is equal to 1. 2 times negative 3 is negative 6 plus y equals 1. And we'll add 6 to both sides to get a y value of 7. Okay, now we have our solution, both our x and our y. So we say the solution to this system is the ordered pair negative 3, 7. Okay, in our final example for today, we are going to take a look at solving a system of 3 equations and 3 unknowns. Now, in order to solve a system of 3 equations and 3 unknowns, we have to pare it down to 2 equations with 2 unknowns. And the way we do that is we just take 2 equations at a time. So let's start by taking these top 2 equations. You can see that I can eliminate one of my variables here. I can eliminate my y. So I'm going to combine them by saying 5x plus x. 5x plus x is equal to 6x. A positive y plus a negative y is going to cancel each other out. A 6z plus a 10z gives me 16z. And 3 plus 9 is going to give me 12. So I've combined these first 2 equations to give me 6x plus 6z equals 12. Now I'm going to do the same thing with the second 2 equations here. So I am now going to put my line under here and combine these two. X plus 5x is 6x. A negative y plus a positive y, the y's cancel out again. A positive 10z plus a negative 2z gives me 8z. And then 9 plus a negative 9 gives me 0. So you can see now I've successfully whittled down my 3 equations to 2 equations with 2 unknowns. And I actually have the same coefficient on my x's. So now instead of adding these 2 sentences together, I am actually going to subtract them so that my x's will cancel out. 6x minus 6x cancel each other out. 16z minus 8z gives me another 8z. And then 12 minus 0 is equal to 12. So I can divide off both sides by 8, and I get z is equal to 3/2. Okay, once I found my value for z, I can take that value and I can substitute it back into one of my second equations that I found. So let's take this second equation here that I had, and let's see if we can find the value of x. So 6x plus 8 times z, which was 3/2, is equal to 0. So 6x plus, this is 24/2, which is really 12, is equal to 0. We'll take that 24/2, or 12, and move it over the other side by subtraction. So now we have 6x equals negative 12. Divide both sides by 6, and x is equal to negative 2. All right, now we have both our x value and our z value. We can go back to one of our original equations and solve for y. So let's take our bottom equation here. We'll have 5 times negative 2 plus y minus 2 times z, which is 3/2, is equal to negative 9. So that gives me negative 10 plus y, and this is negative 3, equals negative 9. Combining like terms on the left side, we get negative 13 plus y equals negative 9. Add that 13 over, and we get y is equal to 4. All right, so we have both our x, our y, and our z. So we say that the solution to this we say the ordered triple, that is the solution to this system, goes like this: x, which is negative 2, comma y, which was 4, comma z, which is 3/2. And that's how you solve a system of 3 equations using elimination.